Okay guys, so we're looking at theoretical probability. Theoretical probability, I suppose it's the probability where if you take a dice and a fair dice, and we're looking at things like, what's the chances of me rolling a 2, or what's the chances of me rolling an even number, okay? And in theoretical probability, well, here's our formula, our way of finding out the probabilities. It's probability of an event happening is total number of possible outcomes over the number of successful outcomes. Also, the probability of an event not happening is 1 minus the probability of an event happening. And just remember that the probability is always between 0 and 1. Okay, so it's going to be a decimal or a fraction, but it's always going to be between 0 and 1. So let's look at this dice, or die. It's a fair die, so there's equal amount of chances that a 1 or a 6 or a 5 or a 4 or a 3 will come up. So I suppose my question to you would be, what's the chances of me rolling a 5? Well, let's have a look with regard this formula or this method. The chances of me rolling a 5, well, the total number of possible outcomes is 6, because I could roll a 1, a 2, a 3, a 4, a 5 or a 6. And the number of successful outcomes, well, I asked you what was the chance of rolling a 5. Well, there's one chance of rolling a 5, so the probability of me rolling a 5 is 1 out of 6 or 1/6. You could write it like that, you could write it as a decimal, or you could, I suppose, write it as 1 out of 6. Okay? Next one, what's the chances of me rolling an even number? Well, again, total number of outcomes, there's 6. Even numbers, so 2 is even, 4 is even, 6 is even. So there's 3 chances out of 6. And again, that can be written as a half. Okay? Next then, what about the probability of an event not happening? Probability of an event not happening is 1 minus the probability of an event happening. Okay. So what if I said, what's the probability of rolling, of not rolling a 5? Okay. Not rolling a 5. Well, that's 1 minus the probability of rolling a 5. Well, the probability of rolling a 5 we've just saw up here is 1/6. So the probability of not rolling a 5 is 1 minus the probability of rolling a 5. And that is 5/6. Okay. Okay, so this is experimental probability. Experimental probability is a little bit different than theoretical probability. Theoretical probability, say, looks at the dice, says, okay, there's 6 sides to the dice, so there's an equal chance of each of the 6 coming up. So 1 chance out of 6 for a 1 coming up, 1 chance out of 6 for a 2 coming up, etc., etc. Experimental probability, though, is a bit different in that we, I suppose, look back at what previously happened and then we draw conclusions from that. So, with experimental probability, like the name says, we do some experiments or some trials, and based on what has happened, we will use what has happened previously to, I suppose, predict what's going to happen in the future. So, I have a die here, and I've rolled it 100 times, okay? And 1 has come up 4 times, and 2 has come up once, and 3 has come up 50 times, and 4 has come up 10 times, and 5 has come up 10 times, and 6 has come up 25 times. Now, based on theoretical probability, we would say there's 6 sides, so each of them has an equal chance of coming up. However, with experimental probability, if I look at this, I would be thinking, hold on my next roll, the chances of 2 coming up is very slim, whereas the chance of 3 coming up is pretty good. It's actually a half. Okay, so using experimental probability, what would the chances of me rolling 4 be? Well, total number of trials is 100 over number of successful trials. Well, I successfully rolled a 1 4 times, and that equals 1 out of 25. Okay. Again, what would the chances of rolling a 3 be? Well, 100 trials, 50 of those successful, so like I said earlier, chance of rolling 3 is a half. Also, I suppose the chances of not rolling 4, say, is the same as the last one, 1 minus the chances of rolling a 4. And the chances of rolling a 4 is 10 out of 100. So the chance of not rolling a 4 is 90 out of 100, which is 9 out of 10. Okay? And lastly then, relative frequency. Well, relative frequency is the probability of an event multiplied by the number of trials. So for instance, the probability of rolling a 6 is 1/5. Okay, so it's not a fair dice this, right? It's 1/5 chance of rolling a 6. If I roll the die 100 times, how many times would I expect to roll a 6? Well, it's the probability of rolling a 6 multiplied by the number of trials, which is 100. Okay. Sorry, actually, I'm wrong there. It's not 1/6, it's 1/5. And multiplied by 100, which will give me 20. So I would expect to roll a 6 on this die when the probability of rolling a 6 is 1/5. If I rolled the die 100 times, I would expect to get a 6 20 times.